good point. Where the variable is declared, we can determine not only how long does it survive, but who can see it. Now we saw at this point three different things. The instance variables, things that were associated with the class, the particular constants, and things that were defined in methods in local data. Okay, so you just know about those. Okay. So instance data, what they're good for, and how Illinois had two die with different face values because they each have a copy of the face value grid. And also the principles of encapsulation that are pretty much universal across most languages. Okay, the interface is basically what's available to the outside public, and I control that by applying a visible with the visibility modifier. Okay, so four visibility modifiers, four visibilities rather, three modifiers. Default is what you get if you don't say anything at all, and we've seen public and private at this point, and defaulting it. Okay, and you should know why public instance variables are bad, private is good, and method depends on the situation. Why do we have private methods? Well, generally because otherwise public ones will get too big. Okay? Or you may have common features in several methods used that aren't really useful outside of the class, so you define them as private. And we saw some examples of that. Okay, more terminology, accessors, mutators, more commonly called propagators and setters. And it's only a convention, but it turns out that conventions are highly useful. Basically, if you have a getter or a setter, you define a property in the class. As long as you have that format. You don't even have to have a variable underlying it. Okay? The fact that you have a getter or a setter says I have a property I can read or a property that I can modify. And tools will use that to wire classes together. And part of the convention is that because I'm using what's called camel case on the names, where I capitalize subsequent words. So the X is capitalized because it's a subsequent word from get, and the corresponding variable would be to take that X and make it lowercase. So everything after the get, the first character is made uppercase by putting into getter, lowercase for the variable name, and that's part of the convention. Okay. So you have to know, well, basically, how does the flow control go through methods? So we've seen lots of examples of this now. Okay, this is still funny diagram that we saw earlier. And more specifically, how do I declare a method? What exactly is the header? What does it look like? Okay. So this is before I put modifiers on, like probably private. Okay. So I start off with a return type, the name of the method, and then the formal parameters separated by commas, each of which looks like a little declaration with no initialization. And formal parameter, more terminology. Possible method. And then the body is what actually does the work. And so far, all the methods we've seen have had to have bodies. We'll see eventually that that's not really the case, but that's in the midterm. Okay. If I have a type, then I have to have a return statement that returns the value of that type, or that can be converted to that type by whitening. If I say void, which means it doesn't return anything, then I can either have a return statement with no value first because it's not returning a value, or I can just run into the right phrase. And again, how local data works. So return statement. And again, there's a simple model for passing the parameters, which of course you have to know, which is by copies. I take the actual parameters in the call, copy them into the formal parameters, run the statements in the method, return whatever result, and then I throw away the formal parameters and all the local variables. And nothing is ever copied back. I can never return anything through the parameters. Although I can possibly affect something through the parameters, that's slightly different. But that we'll reserve till the next chapter. Okay, so local data, again, how long do things live? Okay, so local instance and static. I talked about that already. And the format of the constructor. The text is a little bit vague about when you get a default constructor. So here you're getting sort of the full story. If you don't define any constructors, the compiler will define one. You always have to have a constructor. If you define some, the compiler assumes that you know what you're doing, so it won't define it. Okay, and then GUIs, I said that you should know how the interactivity comes about with events and listeners. Okay, that's a principal sort of thing. So what events are, we haven't seen a whole lot of events, but we've seen some with buttons, checkboxes, and so on. You know, writing a class, create a listener, add to the component, and so on. You know, events are just objects like everything else. Everything except for the types. And we saw push buttons generate an action event. All except one component we've seen so far is generating an action event. Okay? Text fields as well. Okay. Now, last chapter, as I said, you know, like we just covered that, so hopefully that's fresh. But two main things: decisions and repetition. And to work all those, you have to know Boolean expressions. So how flow of control works? Okay, so conditional, these three kinds. Again, the syntax is simple. You know, if with an if statement, parentheses, and executes one statement, which may be a block. Okay, condition is true, you do the statement, otherwise you skip it. And of the Boolean expressions, if I want to take two numbers and make a true-false by relation, I use one of these six. The only ones that remember particularly are the equals one, which is double equals character, and not equals, which is a exclamation point followed by equal character. And those spaces are the middle of those. With logical ones, I have the exclamation point by itself, or double ampersand, double virtual bar, or not, and or. Those are short circuiting, so you should look at some examples to be sure you know how that works. The if else has an else clause. Again, we've used that a reasonable amount by now. And usually, in check style, will always require you to put a block with if or if else. You might, again, this conditional operator is a not so critical thing. There might be a question on that. It doesn't hurt to know if you're on top of everything else. The switch is somewhat complicated in terms of syntax and how it works, but you should also know that. That's sort of a fundamental construct that most languages have. Although, unfortunately, the syntax is different from language to language on that. So break is required to, in general, to get out of each of the cases in a switch. It's also possible to use it in a file or do a fork, but I don't think we've seen any examples of that, and it's not terribly good practice. Okay, some things on comparison. We saw basically it was dangerous to compare floating point values. Characters compare based on their Unicode, which is a value which is somewhat arbitrary, and all I want you to know is the numbers are less than numerals are less than characters, and capitals are less than lowercase characters. You know, just in case that comes up. Strings. I never use the equal operator for strings. I use the equals method. Generally, if you use the equals operator, it will not work. And you can play with that in the lab. So. With objects, it's good practice to use the equals unless I want to say that two objects are the same object. And again, I can't use the relationals on objects, in particular strings, so I have to know compare to, which does what. You should know what the equals operator does for objects. Okay, basically, there are two things aliases of each other. And for most cases, I'll use equals, which will tell me logically are they equivalent. And if you're writing your own equals, which we did in the lab, the lab version is quite tougher. It's a little bit more complicated than that, so you can ignore that for the moment, but I comment on what you have to do down there. Okay, loops, three kinds of loops, why you should use each of them. Okay. So while loop you use if you don't know in advance how many times you're going around. Okay. Nested loops, no special rules there, but it's a good test if you're able to keep your wits about you. Do less commonly used. Well, I want you to do something at least once. Okay, example of that. For loop is the most complicated one, but it's extremely common, so it's worth knowing. What the different sections do, what they do when they're not there. Example, so this is the proper way of doing a counting loop. Printing out the numbers from 1 to 5. And some other examples. What happens if the section is left out? I might ask that. And then we saw at the end, again, some details. How do you determine the source of an event? And how do I pop up a dialog box? Unlikely to ask you that, although it would be fair game. I'd say if you're on top of everything else, then learn the graphics things. Okay, it won't hurt you. Certainly with checkboxes, that was the only one that had a different type of event. This is an item event. And radio buttons go back to action events. Okay. So that was sort of all the material that we had. Now,